The Viking wood code that outlasted iron and honestly humiliated modern engineering. There's a moment, when history stops being romantic and starts being, a bit embarrassing for us. When you realize that some medieval builders were quietly pulling off engineering feats that, frankly, modern construction still struggles to match. Iron rusted into red dust. Steel failed, but the wood stayed. Whole beams, load-bearing, still doing their job centuries later. That's not nostalgia. That's performance. And once you see it, you really can't unsee it. This isn't a story about Vikings being clever for their time. That phrase, honestly, needs to die. This is about a system of material science, environmental timing and structural logic that, let timber outlive iron itself. Not by accident, by design. And if you're into history, preparedness or long-term survival, this knowledge isn't trivia. It's a weapon. Let's get into it. The mistake modern builders keep making with wood: most people think wood fails because it's weak. That's wrong. Wood fails because it's rushed, mistreated, and forced to behave like steel. Medieval builders never made that mistake. They didn't treat timber as a dead resource. They treated it like a living material with rules. Break those rules and, the structure dies early. Respect them, and the structure can outlast empires. Archaeology keeps exposing this uncomfortable truth. Dig sites across northern Europe show the same pattern over and over. Metal fittings corroded beyond recognition, iron nails eaten hollow, hinges gone. And right next to them, wooden beams still squared, still dense, still holding their geometry. Not preserved in amber, exposed to soil, moisture, freeze-thaw cycles. Yet there they are. That survival wasn't luck, it was process. Why timing mattered more than strength? The first rule was knowing when to cut. Medieval builders didn't harvest trees when it was convenient. They harvested when it was correct. Winter wasn't just preferred, it was mandatory. During the deep cold, sap retreats. Moisture content drops, insects go dormant, and fungus, it loses its advantage. Cut a tree in the summer and you're locking sugar, water and decay straight into the grain. But if you cut it in the winter, you're starting with a cleaner, tighter, more stable material from day one. This wasn't superstition. It was observation refined over generations. Some builders tracked temperature patterns while others watched lunar cycles, not because of mysticism, but because tides, sap flow and moisture levels all move together. They were, in a sense, reading nature like a field manual. For anyone today building off-grid, restoring timber, or even just selecting lumber, this, it really does matter. Dormant season wood behaves differently. It shrinks less, twists less, and, it feeds fewer organisms. You don't need medieval beliefs to understand this. You just need medieval timing. How patience turned raw timber into a superior material. Once the tree hit the ground, the real work started. Raw wood is unstable, you see. It wants to move. It wants to crack. Modern industry tries to bully that behaviour out of it with kilns and speed. But medieval builders, they did the opposite. They let the wood settle into itself. Air seasoning was slow, deliberate and controlled. Logs were stacked with space between them so air could circulate freely. They were kept off the soil to avoid ground moisture and, fungal invasion. The ends were sealed with clay, resin or tar to slow moisture loss and prevent splitting. This wasn't storage, it was transformation. Depending on thickness, seasoning could take months or even years. And, the payoff was enormous. Seasoned timber became lighter, stronger relative to weight, and dramatically more dimensionally stable. It behaved predictably. It stopped fighting the structure. Modern lumber often skips this stage or, compresses it into weeks. And then people wonder why beams twist, walls crack, and joints loosen. Patience wasn't a luxury, it was structural insurance. If you're building anything meant to last, even partial air seasoning beats rushing every time. Why wood survived where iron failed? Iron loses its strength because the environment attacks it. Oxygen, moisture, salts. Rust never sleeps. Wood is different. When treated correctly, it doesn't fight the environment. It collaborates with it. Medieval builders, they really mastered natural preservation long before chemical treatments even existed. Pine tar was, without a doubt, the heavyweight champion. Thick and resin-rich, it was heated until it flowed, then brushed deep into the grain of the wood. This process sealed out water, resisted insects, and, interestingly, added flexibility instead of causing brittleness. Some wooden structures, still standing after, 800 years, owe their remarkable survival almost entirely to repeated treatments with tar. Coastal moisture, snow load, freeze cycles, these challenges were no match. The tar turned the wood into a sort of self-shedding surface that simply rejected rot. Other methods existed too. There was saltwater soaking, tannin-rich soils, and smoke curing. Shipbuilders, for example, would mix tar with ash and animal fats to protect hulls from water and marine organisms. These weren't folk tricks, They were empirical solutions, refined under pressure. For modern survivalists, this really matters. Pine tar is still available and it's still effective. Just heat it gently, apply it warm, let it soak, and reapply over time. That beam will outlast pressure-treated lumber without leaching chemicals into your land. Here's where medieval engineering really flexes. Wood moves, it expands, contracts, breathes. Metal fasteners don't. When you bolt wood into rigidity, stress builds. Eventually, something gives. Usually the wood. Medieval builders solved this by eliminating metal wherever possible. Mortise and tenon joints, dovetails, wooden pegs, interlocking geometry that allowed movement without failure. These joints flexed with the seasons. They absorbed shock. They distributed load instead of concentrating it. And here's the part modern builders miss completely. These structures were repairable. One beam could be removed and replaced without tearing everything down. That's modular construction centuries before the term existed. If you're building a cabin, shed, or long-term shelter, even basic joinery matters. Saddle notches, peg tenons, lap joints. You don't need perfection. What you really need is compatibility with movement. Just let the structure live. When you strip away the romance, the system is, well, brutally practical. Harvest during dormancy. Cold season, low sap, minimal moisture. Air season the wood under cover with ventilation. Keep it off the ground, seal the ends, and let time do the work. Preserve with natural treatments that repel water and insects while allowing flexibility. Pine tar, smoke, resin oils. Build with joinery that respects movement instead of fighting it. Reduce metal, increase adaptability. That's it. No magic, no lost technology. Just a mindset that prioritized endurance over speed. You're not copying medieval builders. You're applying a survival-tested system that already outperformed modern shortcuts for over 1,000 years. Why this still matters in a World War II and beyond mindset. World War II taught the modern world a hard lesson about logistics, resilience and material failure. Steel was powerful, but, supply chains were fragile. Infrastructure that couldn't be repaired locally became liabilities. Medieval timber systems were the opposite. Local materials, local knowledge, repairable with hand tools. No dependency on factories or chemicals. That's not backward. That's resilient. In a long-term disruption scenario, wood treated the old way beats steel you just can't replace. A joint you can recut beats a bolt you can't source. And, well, a beam that flexes beats one that snaps. This is why, serious preparedness circles are quietly rediscovering these methods. Not as cosplay, as insurance. If you're sourcing timber, prioritize dormant season cuts or lumber harvested in the winter months. Ask questions. Timing matters. If you already have wood, elevate it, ventilate it, and, just give it time. Even a few months improves stability dramatically. Experiment with pine tar on outdoor beams, posts, and structural elements. Heat, brush, absorb, repeat. Learn basic joinery. You don't need cathedral-level craftsmanship, honestly. You need joints that move instead of crack. Build with the assumption that repair will be necessary one day. Design for access. Design for replacement. That's medieval thinking, and it works. The real secret wasn't the wood. The real secret was humility. Medieval builders didn't try to dominate nature. They studied it, timed it, and, stepped aside while it did the heavy lifting. They let cold, air, resin and time strengthen their materials instead of rushing them into failure. Iron gives brute strength. Wood, treated correctly, gives endurance. And endurance is what survives centuries, climate shifts, and, collapse. If this deep dive sharpened your understanding of historical engineering and practical survival skills, subscribe to Old World Prep. Share this with someone who still thinks medieval means primitive. And stick around. We're here to recover the knowledge that actually lasts.